Hello, welcome to Immutable All the Way Down. I'm James the Cuirot, better known in the community as Chewy. Threw in a few ponies in my talk at the last minute, because why not? So I'm a software engineer at Microsoft right here in Edinburgh. In fact, until March, I used to work just down the street from here. I'm a Flatcar Container Linux maintainer by day and a Gentoo Linux maintainer by night. And that's handy because Flatcar's based on Gentoo, and there we go, Gentoo. So I'm sure you're all sick of slides by now, right? Well, you're lucky because this doesn't have any. So I've got 4 demos for you today. We're going to provision Kubernetes in a way that you might not have seen before. And for this, we're going to use Flatcar. But you can use pretty much any distribution that has a systemd version newer than about 4 years old to do this. But yeah, Flatcar is a community-maintained distro. It's a CNCF project, and it's designed for running container workloads. What makes it special is it's immutable. So if you're not familiar with that, it basically means you can't write to USR as root. Even if you poke about with the block device, the system will eventually notice and panic, which is great for security, not so good if you want to update or install packages. But then, you know, do we want to be installing and updating packages on our production systems? Maybe not. You know, we're supposed to be herding cattle these days, not coddling pets. But the cattle approach has some downsides, so let's see if there's a middle ground. So for the first demo, I'm going to introduce you to the concept of systemd system extensions. Second demo, we're going to use systemd sysupdate to update the system extension. The third demo, we'll build on that to deploy a Kubernetes cluster locally on this machine. And the fourth demo combines all that, but adds the Cured Kubernetes reboot daemon to update things without disrupting your pod workloads, and that will be done into Azure. You can use any, we'll use Cluster API for that, and you can use any provider that supports Cluster API to do this, like OpenStack or AWS might work. So, yeah, now I'm sure some of you secretly enjoy your dessert before your main, so we're going to start with demo 4, because that just takes a while actually. So I'm not going to go into the nitty-gritty of demo 4. There's quite a lot of code behind it, but the relevant parts you'll see in the other demos. So I'm just going to load up the code, and I'm going to set up a kind cluster. If you're not familiar with kind, that's basically Kubernetes in a Docker container, useful for local testing and development. And we're going to use that to then deploy our real Kubernetes cluster in Azure. So that's fired up, so we'll get it generating the cluster API YAML, and that will take a while, so we'll just leave that go. On to the first demo then. So what is a sysext? Well, it's a file. And what kind of file? Well, in this case, it's a squashfs, which is a compressed Linux file system. You can have other forms of sysext. They can just be X4 file systems. The modern type is irofs, which has been designed specifically for this use case. But yeah, squashfs is the sort of traditional format. And now, these are immutable, just like the immutable distros that you might run them on, so it's cryptographically protected, and you mount them on your system like any file system, but they get overlaid on top of USR, so it becomes part of your wider system. And that's done using overlayfs, which is a Linux kernel feature that's used to power Docker and, say, live USB distros. And you might think, well, that sounds a bit like a container. Why don't you just use a container? But there's some things you don't want to run in a container, like Kubernetes. You're like, wait, Chewy, didn't you just put Kubernetes in a container with kind? Yes, but not in production. So, although one of the people outside, I gather they are putting Kubernetes in a container, but there we are. You have options. So we can mount this to have a look in it, but we'll just use the squashfs tools. So what's in this thing? Well, we've got kubeadm, kubectl, kubelet, various bits needed to make Kubernetes work, and some systemd stuff. So these are static Go binaries, which makes this sysx pretty much usable on any distro, but sysx can be specific to a distro and a release. They might have, dependencies on specific system libraries, but generally you want to make them generic. It really depends on your use case. As such, there's some metadata that goes with the sysx that's just a file inside it, so we'll just take a peek at that. This ID field is designed to match the OS release in the etc OS release file, but you can use a special string any, which means it will work anywhere. Obviously, the CPU architecture can't be generic, so we put that in there. And that last line just tells systemd, hey, there's some systemd config in here, so when you merge the sysx, make sure you reload your config. And we'll just take a peek at that config. So there's a unit which we attach to the multi-user target, which is the general systemd unit for the system is running. And it says, as long as the system is running, keep kubelet running, which is what we want. Just before we fire up Flatcar, let's just see what that looks like. So Flatcar ships images in a variety of formats. This is the QEMU one for using, the QCOW2 for using the QEMU. And we include a shell script just to make it easier to fire that up. And generally, when you use Flatcar, you want to provision it with some YAML, which looks like this. This gets passed to a provisioning tool called Ignition. It's a bit like Cloud Init, if you're familiar with that, but it's not written in Python. It's fairly similar. So this just basically says, fetch this, sorry, hopefully you can see that. Fetch the sysx from this web server, which you'll notice is a local IP, because I'm just going to run that on my machine, and write it to this path. The rest isn't strictly related, but Flatcar normally updates itself after a short time, and we don't want it to do that during the demo, so I've disabled that, and the rest is just to make the demo easier. Now, Ignition consumes JSON, not YAML, so we use a special tool called Butane just to convert it, and that's just done there. Run the Python built-in web server, can be any basic web server, and we'll fire up Flatcar. It's just the serial console coming up. Excuse me. Actually, while that's coming up, we'll just check on demo 4. Okay, that's the first bit done. Start deploying the cluster. Ugh. Yeah, I was afraid that might happen. This worked the second time I did it last time, so I'll just cross our fingers and yeah, I'll come back to that. Right, so that's Flatcar up. Doesn't take long to boot. It's a very minimal distro. So just run my script. Oh, sorry. So let's see what we've got. So it's put out sysx, it's downloaded it from the web server, stuck it in that directory down the bottom there, but systemd won't actually notice it yet because it's looking in etc extensions. So what we'll do is we'll create a symlink to that sysx into that directory. There we go, ask it again, and there you can see it knows about it, but it's not actually active yet. So these are the ones that are active. If we try and run, say, well, try and check if Kubernetes is there. It's not there. Kubelet's not running. So what we need to do is tell systemd to refresh, because you don't want it to just apply the thing straight away when you're not ready. You might need to take some initial steps first. So we'll apply it now with the refresh subcommand. Bunch of stuff happens. So it's picked up our extension. It's unmerged USR and remerged it with the extension included, and now we have Kubernetes there. Kubelet's running. It's broken. That's only because we haven't configured it yet. And yeah, we can check the version. Now, just to highlight, that was almost instantaneous. There's no package installations going on here. It's just literally flip one to the other. But yeah, that's the first demo done. Shut that down. Hooray. Let's just see how that's going now. Try that again. Might have to wait and see on the fourth demo. That's the online one. The rest's all offline. Okay, we'll see how that goes. Demo 2. So we're going to build on that and use systemd sysupdate to update the version of Kubernetes. So here's our YAML again. We've added a few things. So got our we're creating the symlink immediately now, so it'll just be there. And we're also including this sysupdate configuration file, which I'll show you in a second. And normally sysupdate runs on a timer, but I've just disabled that so that I can demonstrate it a bit better. And that next snippet I'll actually explain more in demo 3. YAML to JSON. Now, let's just look at what the web server's serving. So we've got our old sysx there and our new one and the configuration file. Just take a look at the configuration file. Now you might think, oh, sysupdate's just for sysx. It's not actually. You can use it for anything. But in this case, sysx are regular files, so that's what we tell it. This is where we're writing them to. This is where the symlink is. And this is where we're downloading them from. And when it's looking for new versions, this is the pattern it needs to match. So we're matching that specific version of Kubernetes 1.33. whatever, and the %A matches the CPU architecture. Now you might think, oh, is it just going to poke my web server, just randomly looking for new versions? No, that would be silly. So we have this SHA-256 sums file, which lists all the sysx we have and includes a checksum, which it can use to verify. So fire up web server, fire up Flatcar again. Let's see how we're doing over here. Maybe. Okay, run the script. Okay, so we've already got Kubernetes there on the older version. Systemd already knows about it. We've got the old sysx there, not the new one yet. Obviously, symlink's pointing at the old one. And systemd sysupdate hasn't done anything yet. So let's fire it up. So now you can see it's fetched the SHA-256 sums file, and it's looked at that and gone, oh, there's a new version. I'll grab that. Let's see what it did. It's quite a lot of stuff, so basically what I just said, but yeah, downloading it, swapping the symlink. Let's have a look. Got the old and the new there, pointing at the symlink pointing at the new one. Now it's Kubernetes is still actually, when you run it, is pointing at the old one, and again, that's because we haven't done this refresh. And this command will do the same thing, but this is doing it through sysx systemd units, just another way to do it, and you issue a reload. There we go. Now if we ask it, it's the new version, just like that. So that's demo 2. Let's see, demo 4, yeah, okay. So, sorry, just take a drink. Demo 3 is a little bit more involved. We're going to have a control plane, 2 worker nodes. So let's look at the YAML for the control plane. Now, got the same stuff we had before. Got a little bit of network configuration here for an additional interface so it can talk to the other nodes in the cluster. Kubernetes needs to know its own host name, otherwise it doesn't work. Ignore that bit. And we've got the sysupdate timer on this time, but on quite an aggressive schedule, so we're not having to wait for ages. Now this bit at the bottom, I don't like this. This is horrible. And I was looking into why is this like this and can I make it better. I think with recent systemd versions they've made it possible. But basically what this is doing is it's instead of just relying on systemd sysupdate to swap the symlink, we want it to do a bit more than that this time and also write this reboot required file. And this is one of the only ways to do that at the moment. But yeah, I think it could be done a better way. But yeah, I'll explain what that reboot required file is for in a minute. And we've got a unit for kubeadm, which just to initialize the cluster, just extend the timeouts, some network config, and blah, blah, blah. Okay, YAML to JSON, web server. Got some extra arguments on QEMU this time, just to add that network adapter. Also worth mentioning at this point the snapshot argument, which we use to, it tells QEMU not to persist its changes to disk. So we can spin up as many VMs from this one image as we like, and they'll all come up pristine, which is very handy for demos. So, come. I'm scared to look at this now. No change. Oh man. Don't know if it's worth just trying that again, but we'll probably run out of time. Right, that's up. Demo 3, run control. Okay, so when this is ready, which it should be, it'll write this directory with a config in it. Good. Got our control plane node. It's not ready because we don't have a CNI yet. Let's apply Calico. Just give that a second to work. Should see something. Yep. Okay, get nodes. Right, we're ready. Check a look at the pods. Right, not quite ready. There we go. And that'll have generated a token for us so the other nodes can join. And we'll just write that token out to the handy little share that I've got so where the other nodes can pick it up. And we'll watch as these other nodes come up. So this is the first worker. Again, similar YAML, extra interface, host name, and kubeadm this time just joining the cluster instead of initializing it. YAML to JSON, fire it up. And while that's going, we'll get the second one. Same again. So this should come up any second now. There it is, first node. Second one should pop up. There it is. So what we'll do, run my script. 3. So let's see what we've got. So got the old sysx, symlink at the old one. The reboot required file hasn't appeared yet. So sysupdate hasn't kicked in yet. Just give it a moment. But while we're waiting, what that's going to do, well, actually it's not going to do anything in this case, but what you would use it for is with the likes of Cuirot, which watches out for this file, and it will then take action to mask your node, evict all the pods, move them elsewhere, reboot, apply the update effectively, and then repopulate the pods. And it will do all that automatically without disrupting your workloads, and it's highly configurable. I'll show you a bit of that in a minute. Should be done by now. Yep, there's our file. Symlink's updated, and we can see that sysupdate did its thing. So if we tell this to reboot, and I'll do the same with the second one. Probably should have checked that reboot required was there, but never mind, I forgot to do that. Should have done it by then. There we go, it's updated. And hopefully the second one will follow. There we go, updated again, just like that. So that's the third demo done, and the fourth demo, well, oh, it looks like it's actually going to work this time. But, whether it'll be ready in time, I don't know. But basically what was going to happen there was it was going to deploy, again, control plane, 3 worker nodes on the old version, and then we were going to kubectl apply some Kured configuration, and that has, I'm not an expert on Kured, but it has umpteen options to say how quickly do you want to update your nodes, you know, do you want a big delay between them, how many to do at a time, do you want to filter them, what time of day do you want to do it, and set up notifications and all this kind of thing, and it will all just happen automatically. So hopefully now you might reconsider immutable distros if you haven't, now that you know you can use sysx to provision them and update them very cleanly and quickly and safely. Thank you. Any questions?